Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. I'm going to solve a problem for you right now, a math problem that appears in this book, the official SAT study guide. It has 8 exams in it. Each exam has 3 math sections. The problem that I'm about to solve appears in exam number 8, section number 5, page 860, question number 20. There are 20 questions in this section. This is question number 20, which means it is, according to the College Board, the most difficult question in the exam. But you will see in a second, actually it's not that bad. You just have to use the proper technique. The technique that we're going to use here is called, well, I'm giving the game away. Let's take a look at the problem first. If after watching the clip you find it helpful and you wish to purchase the DVDs, or one DVD if you like, of each of the sections, please get hold of me through email. Go to my website at www.prep4sat.com. Tell me which exam number, which section number that you want to purchase, and I will send you out the DVD for that particular section, which will contain the solutions to all the math problems in that section. If you wish to purchase a set of the entire 24 DVDs, let me know. I also do private tutoring, personal private tutoring, face-to-face tutoring. I'm located in the state of Connecticut. Get hold of me if you wish to hire my services. I do prep courses for SAT, GRE and GMAT. Let's get going. I feel much better because for the last 2-3 days I had no voice, and if you watch any of my clips from exam number 7, you will see that I was not in the best of shape. Let's read the problem. Number 20. You must have the book in front of you. Turn to page number 860 and read the problem with me and solve it with me. Have a piece of paper with you, have a pencil with you and solve it. Don't, as I said many times before, don't just sit there and stare at the bloody screen passively. That's not how one does a math problem. So do it with me. It says, if k is a positive integer, which of the following must represent an even integer that is twice the value of an odd integer? Alright, so let's start one thing at a time. If k is a positive integer, the very first thing I'm going to do is, here I'm going to make a note here, k is a positive integer. I'm going to make up a number for k. Let's make up a number. In other words, we're using a technique called plug-in. You probably remember it. They don't tell you what k has to be. All they tell you is that it's a positive integer. When you're plugging in, you should avoid, as much as you can, try to avoid plugging in 0. Because if you plug in 0 in the problem, the whole problem just obliterates. Try to avoid plugging in 1, and avoid plugging in numbers that appear in the answer choice or in the problem. Avoid numbers that appear in the answer choices or the problem. Alright? Very good. And try to plug in a unique number for each of the variables. If there is x, y and z, try to plug in unique number. That way, if one answer choice says x times y over z and the other one says x times z over y, and if you plug in the same value for y and the z, you will not be able to tell which one is the correct answer. You have to have unique value. Which is also, you don't want to plug in 1. That you won't be able to tell what's going on here. Anyway, enough of that. I'm going to plug in 2. Why 2? Because I don't want to plug in 1, and I also want to keep my numbers as small as possible, so 2 is the smallest one. Let's get going. Enough of that. What I'm looking for, so here's what my question reads. If 2 is a positive integer, which of the following must, that's the key word there, must, the most important word, must be an even integer that is twice the value of an odd integer. So I'm looking for something that's an even integer, but that's not enough. It has to be twice the value of an odd integer. So let's get going. A says 2 times k. 2 times k, it is an even integer, but 4 is not going to be twice the value of an odd integer. It doesn't work that way. Let's take a look at B. B says 2k plus 3. 2k plus 3 is going to be 7. It's not even an even integer. It's not even. C says 2k plus 4. Now that is going to be even. 2k plus 4, if my k is 2, that comes out to be 8. It is even, but that's not twice the value of an odd integer. I need something. I'm gonna make a note here. I'm gonna erase all of this now. I'm gonna erase all of this. We need something that has to be twice the value of an odd integer. This is not. Let's look at D. 4k plus 1. You see the problem? 4k plus 1. 4k is going to be even. 4 times k is going to be 8. Plus 1 is going to give me 9. It's not even an even integer. The answer is E. The answer is E. That's all. That's how simple it is. 4k plus must be 2. 4k plus 2. There you go. Now that is an even integer. It is an even integer, and it also happens to be 2 times an odd integer. You see, 10 qualifies. We were looking for something that is an even integer and also twice the value of an odd integer. 10 is it. That's it. We are done. That was so-called the most difficult problem in the exam. The reason it's so simple is because we use the technique called plugging in. Plugging in technique is a beautiful technique. If you see a variable in the answer choices, just plug in. Keep your life simple. If you like, I'm going to go back in the back of the camera just now and see how much time I have gone so far. And if I have time, if you're curious, if you like, I will show you the proper way, if you like, the geeky way, the nerdy way, the classical, traditional, orthodox way, the academic way, the algebraic way. Let me take a look how much time I have. We are about 8 minutes into the clips. That's because I was explaining about which number to plug in and so forth. Let me redo the problem in the classical way. Okay? I'm going to do it here. Very quickly, I'm going to do it on this side here. So let's suppose we have a k. So this is our k. K, as you know, is a positive integer. I'm going to continue here. If k is a positive integer, it doesn't matter whether it's even or odd, makes no difference. All we have to do is this positive integer. So what do you suppose 2k plus 1 is going to be? 2k plus 1 is going to be an odd integer. How do I know that? I know that because if, say for example, the k was 2, 2 times 2 is 4, 4 plus 1 is going to be odd. Let's say k was odd. Let's suppose k was 5. 2 times 5 is 10. Plus 1 is going to be odd again. You see? Whether k is positive or whether k is even or odd, it doesn't matter, because if it's even, even times even is even. Plus 1 is going to make it odd. Or if it's odd, if k were odd, odd times even is going to be even again. Odd number times even number is even number again. But when you add 1 again, it becomes odd. So this quantity is odd. I'm told to look for something which is twice this quantity. You see, twice the value of an odd integer. If k is a positive integer, then this is an odd integer. I'm telling you, this is how you find. This is the difficult part. Going from here to there is where it gives people trouble. You have to realize that if k is an integer, then this quantity has to be an odd integer. It has to be. What is twice this quantity? You've done just twice that quantity is this. That's it. That's your answer. 4k plus 2 was the answer. The answer is C. Right here. Right here. 4k plus 2. Alright? So I did it two ways. I did it the abstract way, the algebraic way, and I did the plug-in way. Either way you like. Send me email, post comments on the YouTube. If you wish to get my clips right away as soon as I post them on the YouTube, subscribe to my channels. And thank you again for watching. And get hold of me if you wish to hire me or purchase the books or purchase the DVD. Alright? Thank you.